So of course we have here feet and we have seconds. So t is in seconds, y is in feet, and we're asked to find the velocity at time t. So velocity at time t is y prime. Remember what I like, since this is a factor, I would like 9 to stay outside patiently. It's not going to make any difference. T prime is 1 times the denominator minus the top times the denominator prime, which is 2t, over the denominator squared. If you don't leave 9 outside, then you're going to have here 9 and then 81 and then 18, and the numbers are bothering me if I can avoid them. But you don't have to. I recommend it, but it's up to you. In time, you develop your own style. Okay, so then I have 9, t squared plus 9, and then this is minus 2t squared over t squared plus 9 squared. And this is negative t squared plus 9. I hope you learn from me to also be allergic to negative leading coefficients. And of course, you're going to factor out the numerator just to have it factored to see what happens next. So anyway, we do have the velocity. This is the velocity at time t. Done. Any questions, please? What is the velocity after 1 second? Okay, so part 2, velocity after 1 second. I have no idea. 1, so there is a negative 9 in front. 1 minus 9 is negative 8. 1 plus 9 is 10. 10 squared is 100. So this is, I'll simplify by 4. So this is 18 over 25. It's velocity, so this is in feet per second. When is the particle at rest? Rest means velocity is 0. That's why I have it ready. So this is negative 9, t minus 3, t plus 3 over t squared plus 9 squared equals 0. When is a fraction 0? When is a over b 0? For a over b to be 0, something must happen. What? Anyone, please? When is a over b 0?
When the numerator is 0.
Yes, exactly. Only when the numerator is 0. So if the numerator is 0, how much is t? How much is t when the numerator is 0?
P would be 0.
T minus 3 times t plus 3 is 0.
Or t minus 3 equals 0.
When t is 3 or when t is negative 3. Since we're talking about time, this is not acceptable because we're talking about seconds. So this is the only time when the particle is at rest. 3 seconds after it starts moving. Good. Part D. When is the particle moving in the positive direction? So that's my page 11. T. 0 to whatever. V of t. A of t. Conclusion. We know that the velocity is 0 at 3. We're asked when is going in the positive direction, when is going in the negative direction. Okay, so remember I have the velocity, so I'm gonna write it here one more time. So I have the velocity, -9 t minus 3 t plus 3 over t squared plus 9 squared. I need to study the sign. I refuse to study the sign of this. It will be a waste of time. Why? Why study the sign of this quantity will be a waste of time? I claim that studying the sign of this quantity is a waste of time. Why?
Because it's harder to like unfactor.
It's
Or
always positive. It's a quantity that is squared. It will be a waste of time to plug in anything in a quantity that is always positive. So now I will plug in 0, to a number to the left of 3 and a number to the right of 3, to study the sign of this. When I plug in 0, this is a negative quantity. This is a positive quantity. So positive times negative times negative. Can anyone tell us the sign here? Zero plus 3 is positive. 0 minus 3 is negative. But I have a -9 in front. This times this times this. What is the sign?
That will be positive.
Very good. Now I'm going to plug in 10. But 10 minus 3 is positive. 10 plus 3 is positive. So now I have positive times -9. What will be the sign?
Negative.
That's it. So now I know that the particle goes in the positive direction 3 seconds, and then forever afterwards goes in the negative direction. Next question. Find the total distance traveled during the first 6 seconds. Total distance between 0 and 3. So this is s, or the function, at 3 minus the function at 0. You could say you don't need the absolute value because it's already moving in the positive direction. True, you could omit those, but you cannot omit them here, the absolute value bars. So s at 6 minus s at 3. Because if you do not put the absolute value, you will be subtracting this distance instead of adding it. So the particle goes this way for 3 seconds and then comes back, and for the next 3 seconds goes this way. But we are adding the distance. If you don't put the absolute value here, you will subtract this quantity from this quantity. Okay, so now I plug in the function in the graphing calculator. I determine at 3, 0, of course at 0 is 0, and 6, and then plug in the numbers. So I'm going to share my screen. And I have right here, I meant this, and clear. Okay, what do I have? I have 9t divided by, parentheses of course, t squared plus 9. And then I plug in, it's redundant, but I'm going to do all of them, 0, 3, and 6. Good. So, s of 3, 1.5, minus 0, plus s of 6, 1.2, minus s of 3, 1.5. So I copied those numbers in here. As expected, 1.5 minus 0 is 1.5, in absolute value 1.5 feet. But 1.2 minus 1.5 is negative 0.3 in absolute value plus 0.3. So the answer is 1.8 feet. Next question. Find the acceleration at time t and after 1 second. Okay, the acceleration. This is not an easy task because I have to differentiate this now. Quite ugly. Okay, not this because it's factored in, is more difficult. So I need this. So I'm going to copy it first as velocity here. V of t, negative 9t over, no, t squared minus 9 over t squared plus 9 squared. I just wanted to have it here so I don't have to look on the other page. Okay, so I'll keep the negative 9 outside. And then I will differentiate using the quotient rule. So this is negative 9 staying outside. The top function prime, 2t, times the denominator, minus the numerator times the denominator prime, bring down 2, subtract 1 from the power, times the inner function prime, which is 2t, over t squared plus 9 to the 4th power. And I am the one telling you not to write on the at this tiny little side of the page, but I do it. So I'm gonna just erase that and let's just do this. Multiply by 2t. Because when I scan it, of course it will disappear and no one will understand what I'm doing. Sorry about that. Okay, I should take my own advice, right? Now, if you do not factor and simplify, if we do not do that, we're never going to get anything. So this is the key. These two words are the key here. Do not square and distribute. If you do that, it will take forever to simplify it. These functions are not difficult, but they're not quite user-friendly either. Okay, so a of t, negative 9 stays outside, still patiently waiting. I'm going to factor out the 2t from both factors, and I'm going to factor one of these from both terms, I meant to say. So 2t is out, and t squared plus 9 is out. Okay, 2t is out, one of these two is out, but one of them is still left in. I reach the point of minus. This is out, but I still have t squared minus 9 times 2. 2 times t squared is 2t squared with minus in front. 2 times negative 9 is negative 18, but with minus in front is positive 18. Now I will do this gladly. And I can simplify factors, not terms. So that's why I had to factor out first. So then I have negative 18t, negative t squared plus 27, t squared plus 9 to the 3rd. I hope you're also allergic to negative leading coefficients. So that was the question, part E. Find the acceleration at time t. And after 1 second. Okay, fine. So a of 1. 18. 1. 1 plus 9, 10 to the 3rd, 1,000. 1 minus 27, negative 26. Okay, let's see if I can simplify. I'll simplify by 2. I'll simplify by 2. So I have negative 9 times 13 over 250. 97. And it has to be in feet per second squared. Finally, when is the particle speeding up and when it is slowing down? Well, I'm back here. I have to find where this is 0. So the acceleration is 0 when t is 0, or when t squared minus 27 is 0, or t squared equals 27. I take the square root. It will be plus or minus the square root of 27, however, only plus. We're talking about time. So t equals the square root of 27. And I'll approximate that right here on the spot. So the square root of 27 is 5.2. So approximately 5.2 seconds. I go to my table. I have 5.2. Acceleration is 0 here, and the t equals 0. I need to find the sign here, and I need to find the sign here. Here's how I find the sign. I refuse to plug in t squared plus 9 is always positive, no matter what power. Positive plus positive. Done. I only plug in here. So I'm going to plug in 1. 1 minus 26, negative. I'm going to plug in 10. 100 minus 27, positive, times 100, positive. So now I can draw the conclusions. Between 0 and 3, between 3 and 5.2, between 5.2 and 6. So can anyone tell us here? What does the particle do? Is anyone with me? Is anyone with me, please? What does the particle do between 0 and 3?
Increasing. It's
Slowing
slowing down.
Yes. Because the forces are against each other. The velocity goes this way, but the acceleration goes this way. Okay. Between 3 and 5.2.
Speeding
What's
up.
Yes. So it's speeding up because they're helping each other. Even if they're both going negative, that's fine. But they're helping each other. Finally, between 5.2 and 6.
slowing down.
Slowing down. Good. Next question. What would we like to look at next? Please register in WebAssign for the